Okay, so we're going to go ahead and start off this video right where we left off on the last video, making a scatter plot to answer these questions. So first thing that I'm going to do is I'm going to go ahead and I'm just going to put these numbers that we've got right here from with his parents down onto our scatter plot. So what I'm going to say is if that's 200, and I'm going to go ahead and just kind of label my x-axis or my y-axis a little bit to kind of help me. So here's 100, and this would be 3, 4, ooh. Why that just went all weird, but okay. 5, 6, 7, 8. So just kind of putting some of these numbers on here. So 2, 3, 4, 500, 600, 700, 800. Okay, so I've got that. And then I can go ahead and put some various different months in here, and I'll go ahead and label my x-axis. So here, this would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just putting some numbers down because I don't really know exactly. Sorry, that's not 10. That was 9. This one's 10. So what I'm going to go ahead and do is just kind of translate some of those numbers over here. So I've got 270, 347. So we started at 200, then month 1, 270, then 347. And then the next one was 431.70. So for month 3, 431.70. Month 4 was 524.87. So we're up here, 524.87. Month 5, 627.36. About here. Month 6, 740.09. So month 6, about here. Month 7, 864.10. So month 7. So we're about here. So you can see that's what that one's doing. Okay. That's going to be the information that we had right here in this table. Okay. So using those numbers where we just had the extra $50 every month. Now we don't have the numbers written down for without adding the $50 every month, but that's in our calculator when we did our table here. So month 0 was 200, month 1 was 220. So I'm going to write these numbers down. So let me go ahead and just kind of create a table here. We're going to have X, Y. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so 0 was 200. Month 1 was 220, and then 242. 220, oops, and then 242. Then after that, we were at 266.2, 292.82. So 266.2, I already forgot, 292.82. Month 5 was 322.102. So we'll do 10. Month 6 and 7, so 354.312. And 389.74. What do you notice though? Without me even plotting anything, what do you notice? These values right here are significantly lower than these. Here we were at month 7 at 864.10, and this is month 7 at 389.74. Okay, so let's go ahead and plot these. So we both start at the same exact initial 200. At month 1, we're here at 220. Oh, I hate that this thing does that. Then month 2, we're here at 242. Month 3, 266.2. Month 4, 292.82. So you can see like we're getting higher and higher, but is it going at a higher rate? Nope. 322, we're still here. 354.31. So we're about halfway. And then month 7, 389. So we're closer. So you can see right here, one of these is getting much larger, much quicker. And that's going to be that one where we added the $50 every month. Okay, so obviously that $50 a month, while it doesn't seem like a lot, it really adds up quite a lot. But I mean, if you think about it as well, if we're talking about over a 7-month period, then $50 over 7 months is an extra $350 in savings, just that in and of itself. So that's why this is going to be increasing. But in addition to that, he's also going to be getting that 10% interest on that $50 that he's increasing by every single month. So this is going to grow exponentially. How long will it take Derek to save $2,000 for the down payment if he continues to add $50 every month? Explain how you arrived at this answer. So here, what we're going to have to do is we're going to have to take this pattern that we have right here and keep continuing on in order to get to it. There's no real set equation that we're going to use to find that outside of having to use the previous value. Because I can't really do it otherwise without some long, complicated thing. So let's go ahead and continue our table and see what it's going to take us in order to get to $2,000. So let me go ahead and extend my table out a little bit here. And that's where I would go. Okay, so month 9. What does that get us? And I would go ahead and continue on with what I have here. So I would have, just like we started, I'd have 1,000.51 times 1.10, and then I'd add $50. Well, what does that get me? It's going to get me $1,150.56. Okay, that's still not 2,000. So I'm going to keep going on my table until I get to 2,000. I'm going to go ahead and pause the video to do that because I don't think you want to sit here and watch me make those calculations. All right, so it looks like after calculating all of this out and filling in the table until I got to a number over 2,000, that it would take 14 months doing this where we started with the $200 and parents give 10% of whatever's in the account at the end of the month and then adding $50. So it takes us 14 months to do that. So let's put that here. All right, so 14 months. Continuing pattern from number 3, we find it takes 14 months. Now let's consider really quick. If it's 14 months, how long did it take us to do it earlier? It took 25 months to get to $2,000. So it's definitely a lot faster when we're doing this with the extra $50 added in each month. 14 months instead of 25. Okay, so last part here is how would you write a recursive routine to model this situation? A function rule. Explain your reasoning for each type of rule and compare your responses. So let's see. So let's go ahead and say our recursive routine would be that a sub n plus 1 is equal to a sub n. And then we take that amount and we're going to be multiplying that by 1.10. And then we're adding 50. If you notice, this is exactly what we did in this table right here, where we took the previous amount from the month before, multiplied it by 1.10, and added 50 every single time. So month before times 1.10 plus 50 gets us the next month. So that's exactly what we have here. And then it would be n equals 0, 1, 2, et cetera, and a sub 0, so that initial value is 200. So this right here would be our recursive rule. Now, as far as writing a function rule, I can't exactly do that. There's no real explicit way to do this because of the type of model that it is. And in fact, I can even show you in the table. Let's see here. If I go right here, I went ahead and I tried to put them side by side, doing what some people might think would be the function rule. So this equation right here, the blue numbers, let me show you. Those blue numbers are that 200, that initial amount, times 1.10 with an exponent. That right there is just the function rule that we found initially. And those values right here in the table line up exactly with those values that we found for that whole entire function rule for the first example. Now, if I go ahead and look here at this equation, I went ahead and I took, okay, let's figure people would probably do, let me take that function rule and just add 50 each month. But if I do that and I look at the table, let's put them side by side. Oop, I guess that already was minimized. Let's go ahead and see right here if I can get this to incorporate. If I put them side by side, and I look at these two tables that I have right here, Y2 does not correspond with this that I have right here. That 270 sure does, but then the next number was 347, but the next number over here is 292. So you see, I can't just take that function rule and just add 50 to it because that's not how it works. There's no real function rule that I could go ahead and use for this equation. So I'm going to leave it right this at our recursive model. So right now you see where sometimes that recursive model is way more useful than anything else. It's not very often that it's going to be more useful, but every once in a while it is. So let me know if you have any questions.